So we begin naming alcohols with the molecule on the top left here. We're going to count the longest carbon chain. 1, 2, 3, 4, 5, 6, 7 carbons. This is a heptane. And to name this then, we have alcohol is the highest priority group. We change the E to an OL. So this will become a heptanol. And in the 1 position is where we will find the alcohol. Now, there are compounds that we can argue that we don't have to put the number 1, number 2 designation on because it's the highest priority and it can be assumed if it's at the end of the carbon chain. But this is one, the alcohol here, we have to define the carbon that it's on. And we'll give you an example as to why. All I did was move the alcohol over 1 position, and this is still a heptane, but the alcohol is in the 2 position. So now I have to call this a 2-heptanol. And so it was very important to distinguish, is it in the 1 position? Is it in the 2 position? Is it even in the 3 position? So this one I'm going to use my usual naming. I'm going to call this heptan 3-ol, but it's the same thing. So 3-heptanol, like that. So it's very important to indicate where that carbon is coming from. So let's add some more substituents onto an alcohol chain. So if we have a compound on the top right here, if I draw the blob around it, count the carbons 1, 2, 3, 4, 5, 6, 7. This is a heptane. We can see that there's an alcohol hanging off, there's an amine hanging off, and there is a chloro group hanging off. And we have to look in terms of priority. The alcohol is the highest priority out of these 3 groups. So if I were to count 1, 2, 3, 4, 5, the alcohol is on the 5 position here. 1, 2, 3, and the alcohol is on the 3 position. So this is the side that's going to win out. The numbering is going to start from this side. So I'm going to clean this up. And we'll start numbering from this side. 1, 2, 3, 4, 5, 6. And I'll put the 7 in there. So the alcohol is in the 3 position, the amine is in the 5 position, and the chloro is in the 6 position. So if I were to write those out, I know that the 1 has the alcohol, the 5 has the amine, and since it's lower priority, I'm going to call it an amino, and the chloro is on the 6 position, so the 6 chloro. So if I were to try to put that all together in one big name, I'm going to start off with the 5 amino because alphabetically the A comes first. Next is going to come the 6 chloro, and then finally the heptane dash 3-ol because it's in the 3 position. And that finishes off this one. What I'm going to do in the next compound is I'm going to complicate things by putting a double bond in. Otherwise, the structure of the molecule is exactly the same. So let me erase this. So the carbon chain 1, 2, 3, 4, 5, 6, 7. What I've done, it's a heptane again. And we know here that I've got an alcohol, an amine, a chloro group or a halogen, and I got a double bond. Still, the alcohol is highest priority. So I'm going to change this last E here to an OL. So that's going to get that final name. The heptane is going to change because it is no longer a saturated hydrocarbon. It contains a double bond, so this has to go to an E. So we're looking for a heptenol. So this is essentially going to be the base chain name, but I now need to start numbering where everything is. This, starting from this carbon 1, 2, 3, it's not because of the double bond that we're starting the number 1 here, it's because of the alcohol. The alcohol is closer to this side on the 3 carbon. So 3, 4, 5, 6, 7. So I need to indicate that this is in the 3 position. I need to indicate that this is in the 1 position. And then I need to indicate that the amino is in the 5 position and the chloro is in the 6 position. So let me tidy this up and we will name this compound. And so I would now call this a 5 amino 6 chloro Don't think I've left myself enough room here. Hept 1 ene 3 all. So in the 3 position here is the alcohol, highest priority, so it gets part of the parent chain name. The double bond is in the 1 position, so the starting on the 1 carbon. Note that the E is disappeared because I have OL here. There's a vowel here, and so I can drop the E in this position. Hept refers to the 7 carbon chain, 1, 2, 3, 4, 5, 6, 7. In the 6th position is the chloro, and in the 5 position is the amino. So I didn't want to complicate it further, but if we were to say put a methyl group on the amino, we would now have to indicate on that nitrogen would be a methyl. So to further complicate things, but it's not that complicated because you know how to do this now. So we're going to look at alcohols on a series of cyclic compounds. So in this case, we have a cyclopentanol. So 1, 2, 3, 4, 5 carbons. And if I were to name this, then it is a cyclopentane. And I am going to just put pentanol at the end of, or all at the end of it. So pentanol. So this is the case where I don't need to indicate the number. This is a very symmetric molecule with the alcohol sitting on it. So no matter where that alcohol is, as long as it's a single alcohol and there's no other substituent on it, I can reference this as the number 1 carbon. It's just automatically implied that that's it. Once I start to now have a, say in this case here, a second alcohol, this is a cyclopentanol again, but I have 2 of them, so it's a diol. So I'm going to start off numbering one of the carbons, and now automatically the other carbon, I want it to be low as well. So I'm going to start the numbering this way, 1, 2, 3, 4, 5. I didn't want to go the other way, naming this 1, 2, 3, 4, 5, because that would give a 1,5 diol. I would prefer the 1,2 diol in the IUPAC naming. So when we write this one out, we're going to see we're going to call this one a cyclopentane. I'm going to keep the E, and it's a 1, 2 diol. So I kept the E because I'm starting here with a D. I dropped the E here because I have the O for the OL. So pay attention to that, please, when you're naming these compounds. And so finally, our last example, again, a cyclopentane, but we can see now if I were to start in the 1 position here, I want to make the lowest numbers, so 1, 2, 3, 4 as a diol, or 1, 2, 3. The 1, 3 is the winner, and so I would name this then a cyclo. I'll try to spell it right. A cyclo. I didn't spell that one right either. Cyclopentane 1, 3 diol. So we're going to try some alcohols where it is not the highest priority group. If we try the molecule on the bottom left, I count the carbon chain, 1, 2, 3, 4, 5, 6, 7. I start with a heptane. I have on it then an alcohol, and I have this substituent, which is a ketone. The ketone is higher priority than the alcohol, so it wins out. Since the alcohol is now a side chain or a substituent hanging off of that group, off the main carbon chain, we call it a hydroxy. So my numbering scheme is going to start from this side, 1, 2, 3, 4, 5, 6, 7. Since the ketone was higher priority, I want the lowest number on that. So this will be called a heptanone. I need to indicate that it's in the 2 position, and now the hydroxy comes out front, and it's going to be on the 6 position. So let me rewrite this to include all that information. So I'm going to have a 6 hydroxy hept and 2 one. Again, I dropped the E because I have a vowel here on the other side, so I don't need the E anymore. And that finishes off that molecule. So the next one, I've gone and thrown in another example. So 1, 2, 3, 4, 5, 6 carbons. So this is a hexane as the base chain name. I have one alcohol here, another alcohol here, and I have an aldehyde. So that's an aldehyde group. It is higher priority than the alcohols, so I'm going to switch this E to an Al. So it's a hexanol, hexanol. And so now these alcohols become substituents that have to be named out front. I also have to keep in mind that I have a double bond here. So this hexane will become a hexene. And not only that, since the double bond is within the carbon chain here, it has stereochemistry, and we're going to have to figure out the stereochemistry for that as well. So a pretty good example here with lots of complicated information. So let's see how we do this. So the first thing I'd like to do is deal with the base chain name again. So I'm going to call it hexane. I know that there's a double bond, so the E has to go and the E here has to change as well. So I'm going to say that I have a hex, and in the 2 position, 1, 2 position here is the double bond. So hex 2-ene, and I can put the 1 here, al, but this is one of those arguments you could have that this is a compound that really only is found at the end of a molecule. So in the number 1 position overall, typically, you can argue that. So you can keep the 1 or you can remove the 1 and it'll still be fine for the naming. I personally like to keep the 1. It doesn't change anything. It's just for my own. I just remember it all the time. So what I've done here then is I've got the 6 carbon chain, the double bond, and the ketone. We now have to indicate where these are. So in the 1, 2, 3, 4, and the 5 position is this alcohol. So I now have an alcohol or a hydroxy in the 4 and the 5 position. And since there's 2 hydroxys, I'm going to call it a dihydroxy. So that's essentially the name for it. The only thing that we haven't done is define the stereochemistry. So I'm going to give myself some room here so that we can start playing with this stereochemistry and determine whether it is E or Z. So when you're dealing with the double bond, what you're looking for then is on either side of the double bond, I'm going to deal with this carbon and I'm going to deal with this carbon. So I've got a hydrogen here and a hydrogen here to fulfill the octet. And what I do is I see on this carbon attached is a carbon here and a hydrogen. The carbon here is higher atomic number, so it's going to get a 1, and the hydrogen here is going to get a lower atomic number of 2. It's lower atomic number, so it gets the number 2. If you don't understand what I'm doing here, go back and watch my E and Z naming video. It'll help clarify. And on this carbon, I have attached a carbon on this and a hydrogen here. So this carbon will get a 1, this will get a 2. So since these hydrogens and since these carbons are not on the same side, they're not on the same side, this is an E conformation. So this double bond here is an E. And now what I have to do is indicate the stereochemistry out front. So I'm going to put then that there is a 2E. I always put a 5. A 2E bracket like that. And that indicates our final conformation of this molecule. So there's stereochemistry in the 2E position. In the 4-5 position, there's a dihydroxy, 2 hydroxy groups. It's a 6 carbon chain, a hex. There's a double bond in the 2 position. And in the 1 position is an aldehyde, so Al.